Hello everyone, welcome to another video. This is the second part of my Gateway API series in Kubernetes, and today I want to show you how we can install the application gateway for containers in Azure. The plan for today is, first I'm going to show you the architecture, what we want to do and how the overall architecture of the application gateway for containers looks like. Then I'll talk quickly about the pricing, and then we already dive into a demo where I show you everything from the setup from a new AKS cluster to the full deployment of the app gateway. As always, if you're interested in the slides or all the demo code, you can scan the QR code or you will find a link in the description. With this, now let's take a look at the architecture. First, we're going to create a new Kubernetes cluster, but you can also use an existing one. So this is the one here in the green box. After this, we're going to install the ALB controller in the blue box. That's the application load balancer. And this is something Azure specific. This application load balancer takes care that it creates the application gateway for containers. Therefore, it has to contact the Azure Resource Manager once. And after it is installed, it doesn't have to interact with Azure anymore. This said, the second resource we're going to create is the application gateway for container. That's a resource living in Azure. This means it's outside of our Kubernetes cluster and it takes care of the processing. For example, load balancing, TLS termination. So you don't need any resources inside our cluster. What's not here on the display is another service or resource we're going to create. That's the gateway itself. And this gateway will give us a host name, and then we can configure in a later video our DNS to point to this host name. This is going to be our single entry to the cluster. This is comparable to the ingress. Additionally, what I forgot to mention is once we create this application gateway for container, this will also act as the gateway class. If you remember from my last video, the gateway class defines what resource or component takes care of all the processing of the requests. In this case, we give the control to Azure. Since we're using Azure services, we also have to pay for it. And there are different components for the pricing. So here you can see a screenshot from the official pricing page. So depending on the region where you are, the prices might vary a little bit. But what you can see is you have to pay for the application gateway for a container itself. So it's around 2 cents per hour. Then you have to pay for the front end. This is the gateway and the host name you get with it. Then the association. This is a bit a tricky name. The association is a link between the gateway and the network of the AKS cluster. You will see it later in the demo how we can set it up. But this is by far the most expensive component. It costs almost 15 cents an hour, so it adds up to almost $90 per month. And the last component you need is the capacity unit. This capacity unit configures how much computing resources you have. So by default, one capacity unit means you can have up to 2,500 persistent connections and you get 2.22 Mbits throughput. If you calculate this, I think with the 2,500 connection, you have up to 1 gigabit. So if you take a look, here I selected East US because that's the cheapest region I could find. With the basic configuration, the bare minimum, it will come to around $113. It's not the most expensive resource, but it's also not free. So in another later video, I'm going to show you how we can host everything inside our AKS cluster or any Kubernetes cluster. Then we don't have to pay for the application gateway, but we also don't get the features. So it depends on what requirements you have and if you want to offload the resource usage to Azure or have it inside your cluster. With this said, let's switch over to the terminal and let's get started with the demo. All right, here in the terminal, first let's define a couple of variables. That's just the basic configuration for our AKS cluster. So it's the name of the cluster, the location, and the name of the resource group. And then we're going to configure a couple more variables that are for the application gateway for containers. So let me paste this in here and let's have a look. The first one is the name of the managed identity we're going to use later. And here it's important that you use the name Azure ALB Identity. If you use a different name, it won't work. Then we provide the name of the namespace where I'm going to install everything. So I call it infrastructure namespace because that's the infrastructure for my gateway and for the setup of the traffic. Then we provide a name for the application load balancer, a name for the gateway, and also the name of the gateway class. Here it's also important that you use Azure ALB External because that's the name of the class Azure provides. If you set it up yourself and you use a different gateway class, so there you could use, for example, Nginx or traffic, but then you don't have the features of Azure. So with the variables, next we have to register a couple provider. So I'm just going to paste this here. The command for this is AC provider register namespace, and then you provide the name of the namespace you want to register. So the four providers we want to register are Microsoft Container Service, Microsoft Network, Microsoft Network Function, and Microsoft Service Networking. You only have to do this once per subscription. So I already have set it up in the past, so I don't have to register it again. And it might also take a couple minutes to register them. But we can also check what the status is with the AC provider show. And then again, we provide the namespace and the name. In this case, Microsoft Container Service. And then we configure the output to be a table. Here we can see the registration state is registered. This means this provider is already registered. So we can do this for the remaining three ones as well. And there you can also see all of them are registered. Maybe a bit hard to see, but we can see here we have the registered and we can also have here the registered. If it's saying not registered or registering, then it means you have to either wait a bit or register the provider. The last requisite we have before I can get started is to install an extension for the Azure CLI. This extension is called ALB. And we need it to install the application gateway. As you can see, I've already installed the latest version. If you have not installed it, it will install it within 1 minute, and then you're good to go. So now we can create our AKS cluster. First, I'm going to create a new resource group, and everything we are going to create today and also in the following videos will be inside this resource group. Next up, I'm going to create the AKS cluster. And as you can see, I provide the name of the cluster, the resource group, and then I have 3 additional parameters. The first one is the network plugin has to be Azure. By default, it is already Azure. I just added it there to point it out. Then we have to enable the OIDC issue. This will allow us to create an intro token so our applications can access other Azure services. And then we also enable the workload identity, and this will use the OIDC issue to get the token. I will link you a video where I explain everything in detail, how Entra workload ID works. But for now, let's just create the cluster and then we can continue using it. This now will take around 5 minutes. So I'm going to stop the video, and once the cluster is created, we're going to continue. The AKS cluster has been created. Now I can download the credentials so we can access our cluster. So this is everything we need to set up our cluster. Now we can go to install the application load balancer. First, we have to install Helm. So if you're using Windows, you can use winget. And if you're using Ubuntu, you can use curl. So it's this command. And as I said before, I will give you the file I'm using myself with all the instructions. So you don't have to write anything, you can copy and paste everything from there. Once Helm is installed, I didn't execute it because I already have it installed. But once you have installed Helm, then we can now actually go into creating the ALB controller. And first we have to figure out the name of the resource group of our AKS cluster. So in AKS, we have 2 resource groups. The one where the cluster itself is in, and the second one that usually starts with MC underscore that has all the components of the cluster, like the load balancer, the public IP address, and the virtual machines. So now we have to get this name. And once we have this name, we can use the Azure CLI to get the ID of this resource group. Obviously, we could also hard code this because we know what the name would be, but I wanted to make it as dynamic as possible. So if you follow the script, you can just copy paste everything and it will work no matter what variables you're using. So once we know this ID, we can use the next Azure CLI command to create a matched identity. And here we provide the resource group and the name of the matched identity. And we are going to use this matched identity in the application load balancer. And with this identity, we can create the application gateway. I'm just going to create this and I'll go back to the architecture diagram and show you what we have done so far. But for now, let's get the ID of the matched identity we have just created. So this again, just Azure CLI, AC identity show with the resource group and the name of the matched identity. And then we query for the principal ID. The reason why we're doing this is because we have to use the ID for a role assignment. And here we combine all the resources we have created before. So we do a role assignment with the principal ID of the service principal or the matched identity. Then we say the type is service principal and the scope is the resource group where all our AKS components are inside. And we assign the role reader. If you get an error message here, then you just have to wait 1 or 2 minutes because sometimes it takes a little bit until the match identity has been created and that the replication has been propagated around Azure. But as you can see, we didn't get an error message, so everything is good to go. Once with this set up, we can query the OIDC issue of our AKS cluster. So this again is, I can show you the address where AKS can send requests for the token. As I said before, I will link a video in the description down below where I explain all the steps we need for Entra workload identity. But this is basically the AKS version of matched identities. So we don't have a username and a password, we just have a matched identity, and then we can link our applications inside the AKS cluster with this matched identity, and then assign this matched identity to other Azure resources. The way we do this is we use a federated credential. So this is what we're going to create here. So we use AC identity federated credential create. Then we provide a name for this federated identity. We provide the name of the matched identity we created before, the name of the resource group, the name of the OIDC issuer, and then we link it to the resource inside our AKS cluster with this last line, the subject. So here it says we use a service account and it's in our infrastructure namespace and it has the name ALB controller SA for service account. This means when our ALB controller, and more specifically the service account, needs access to Azure, it has the link to the matched identity, and then the matched identity has the permissions in Azure. Therefore, our application inside AKS can access the Azure services. So once we have set up all of this, we can install our ALB controller, and therefore we use a Helm chart. So let me paste the command here and then we take a look at what it does. So it's a simple Helm install. Then we provide a name, ALB controller, since that's what we're installing. Then here are the OSC, that's the path where we can download it. Then we provide the namespace where we want to install it. I also provide the create namespace flag, so we create the namespaces in case something is not around. Then the version is currently the newest version. So when you watch this video, there might be already a newer version out there. And the next line here, the skip schema validation, is necessary if you use the newest Helm version, because there's a bug in this deployment, and with version 1.7.9 and the newest Helm version, it will fail with a quite obscure error message. Microsoft has acknowledged this on GitHub, and they said it will be fixed with version 1.8 once it's out. The next line is to set the namespace of our ALP controller. So the first namespace here was where we have our Helm installed. This means where our Helm chart will live afterwards. And the ALP controller is where we install it. I use the same because everything is infrastructure related, so I have it in the same namespace. And lastly, we configure the identity of the ID we set before. This means our ALP controller knows the ID of the matched identity, and this is the final piece of the link. So with this identity ID, the service account knows which matched identity to use, and then it gets access to the Azure services. Again, if you've never heard about Enter Workload ID, it can be quite confusing. So I urge you to watch the video where I explain everything, how it works. Once we execute the Helm install, it should only take around 10, maybe 20 seconds, and this will start 2 pods. So let's give it a couple seconds and then we can check if the pods are already running. And there we see, we have already the 2 pods running, and that's the ALP controller. Additionally, this also installs our gateway class. So what we can do is a kubectl get gateway class, and then the name we configured before. That's the name Microsoft provided. And here we can see it has been installed. The name is here this Azure ALP external. And what's important here is this message. It says valid gateway class. This means everything worked as expected. I know this is a lot of information at once, and the first time I took a look at it, it took me a couple days to understand what's actually happening. So let's switch back to the presentation, to the architecture overview, and I'll show you what we have installed so far. So here we have the architecture again. So what we created right now was this green box, our AKS cluster. And then inside this AKS cluster, we have created our ALP controller, the application load balancer. We also configured this link to the Azure Resource Manager with the matched identity. This means our ALP controller can now configure and create the application gateway for container. This is what we're going to do in the next step. So let's switch back to the terminal and let's install the application gateway for containers. All right, back in the terminal, let's clean this up. And one thing I forgot to mention is we are going to create the application gateway for container now, but technically we are creating an application load balancer, and the application load balancer will create the gateway for us. Again, I will show you all the code, and then we switch again to the architecture and also to the Azure portal, so we will see exactly what we have created. But first we have to do a couple configuration steps. And the first one is we have to figure out the subnet ID of our AKS VNet. Therefore, we just use the Azure CLI. I query the virtual machines inside our resource group, and there I use the first IP configuration and take the subnet of the ID. This works perfectly because I know there is only one. If you have multiple clusters or multiple resources in the same resource group, it might not work. But if you follow the demo, I want to keep it as simple as possible. It's already complicated enough. So you can just copy paste it and you'll get the ID of the subnet. If you paste it here, we can see we have the ID. Next, we are going to get the entire VNet because we have to get a couple resources or parts of the VNet. So I just do a VNet show and provide the ID of the subnet we just queried. Then we can take a look and we have all the information about our VNet here. As you can see, the location, the name, resource group, and so on. And now we take a couple pieces out of this. So first, we're going to copy the name of the VNet in its own variable. Then we copy the resource group of the VNet and also the ID. Next, we're going to create a new subnet. And we're using this subnet to connect it to our application load balancer. This is, if you remember in the pricing, the association. So this is the link between AKS and Azure. To do this, we provide the address prefix. So I chose 10.224.25.00-24, and we also provide the name of the subnet. So I named it ALB subnet because I want to know what the subnet is doing. In case you're wondering why I selected the 10.225, it is in the range of our VNet. So we can query the address space of our VNet, and there you can see it's 10.224-12, and the 10.225 is inside this range. If you would select a range that's not inside your VNet, you will get an error message in the next step where we create our VNet. Speaking of, let's copy the command to create the VNet. So we use AC network VNet subnet create, and we provide all the variables we copied before. That's the resource group name, the VNet name, the subnet name, and the subnet address prefix. Additionally, we do a delegation for our traffic controller, and this tells Azure that the traffic controller has control over this subnet. Should only take a couple seconds, and then we have our new subnets for the application controller. Once the subnet is created, we have to query now the ID. So that's basically the same commands as before. We use the AC network VNet subnet show. We provide the name, resource group, VNet name, and we query the ID. Then quickly check that we have the ID and everything works as expected. The reason why we need this is now we do a couple of role assignments. So the first one is a role assignment of the matched identity we have created before, and we provide this matched identity with the role App Gateway for Containers Configuration Manager. This role is necessary that the application load balancer can create the application gateway for container. As you can see, it takes only like 2 seconds and then it's created. The second role we have to provide is again for our service principal or match identity, and this time we set it on the subnet for the application load balancer which we just created, and here we set the role as network contributor. This again should only take us a couple seconds, and now we can deploy the last step. We can create our application load balancer, and this will then in fact create our application gateway for container. So here the naming is a bit confusing, especially when you get started, but let me copy the command and then we can take a look what happens. Since I wanted to keep the demo as simple as possible for you to follow, so you can just copy paste everything, I have everything inside this one file. I don't have separate files, and as you can see I use this add because that's how PowerShell works. If you're using a Linux, you would have to rewrite it to use end of file, the EOF, but then it would work the same way. Then we're going to save this in a variable, and in the next step we can apply this variable with just a simple kubectl apply, and the -f is the variable we just configured. So I execute this because it will take around 5 to 6 minutes, but while this is running, let's take a look at what we have just deployed. So as you can see here, the type is application load balancer. Then we provide the name of the load balancer we configured before and the name of the namespace. That's going to be our infrastructure namespace where we have everything inside. And lastly, we have the association to the subnet we have created before. And this is the link of the application gateway to the AKS. So this means the application gateway knows how to get traffic inside our AKS cluster. So while this is running, we can also take a look at the progress. So we can do a kubectl get application load balancer. Then we provide the name of the load balancer, the name of the infrastructure. We output it as a YAML, and with the --watch, that's a normal kubectl command, we can see if something changes, then the output will be updated. What is important, the first time you execute this, you see here under these conditions that first you have the reason accepted and the status to be true, and then right afterwards you have the reason in progress and the status still true. If you don't see this in progress, then you know something went wrong in the configuration before, because this means something didn't work and the deployment couldn't actually start. But since it's in progress, it's running right now, and as I said, it will take around 5 minutes. So I'm going to stop the video here, and once it's deployed, we will continue. All right, we are back, and as we can see here, the reason changed to ready and the status is true. This means the deployment has been finished. Also, we didn't get any error messages, but if you have any error messages, you can check the pods in the infrastructure namespace. So these are the two ALB controller we have deployed before. What's important to know is one is the primary and one is the secondary. So if you take at the logs, you might have to take a look at both. So what we now can do is kubectl logs of the first pod. Then we also provide the namespace. And then you can just see what's going on. There you can see it's not much information. We don't see any error message. So this indicates that the second pod is probably the leader. So we're going to execute the same command just for the other pod. And here you can see we have a lot more of log messages, but we don't have any error messages. So everything is great. If something didn't go as expected for you, you will see here the error message. It's usually something about the permissions, that you forgot to create the matched identity or set the right permissions. Even though it looks like a wall of text, it's usually quite helpful. With this, we already have set up almost everything. So now let's switch back to the architecture screenshot or diagram, and let's take a look at what we have already installed. Back again in the presentation. So as before, in green here we have our AKS cluster, which we have already created before. In red, the ALB controller and the link to the ARM manager or ARM. This is something we already have done before. And what we did now is we installed the application gateway for a container. We're going to switch over to the Azure portal there as well. But now we've already set up almost everything we need to use the Gateway API in our Kubernetes cluster. The last resource we need is inside the cluster, and it's the gateway. This is going to be the entry point to our cluster, and that's what we're going to create next. Here in red, the sample app. This is something we are going to create in the next video, and then we can also test the access. And I will also show you how we can have multiple apps with one gateway. With this, now let's switch over to the Azure portal and see all the resources we have created so far. Here in the Azure portal, we can see we have two resource groups. The first one is the one where we have installed our Kubernetes cluster and also where we have created the managed identity. And in the second resource group, we have all the components of our Kubernetes cluster. This means we have here a public IP address, our virtual machines, the VNet, our load balancer, and most interesting here, we have the application gateway for a container. So you can open this, and there you can see there's actually not much you can configure. So here we can see all our front ends. In this case, we don't see one because we haven't created our gateway inside the cluster yet. That's what we're going to do in the next step. Then we can have security policies. This means we can have a web application firewall. This is also something I'm going to show you in a later video. And here we can have a look at our association. So this is the link to the subnet of the ALB, which we created before. If we scroll a bit further down, we also have the usual monitoring information, like we can have some metrics and alerts, but I also have a separate video for this. Now we're almost finished. The last step we have is to create here this front end. The reason why I showed you the Azure portal now is because this gateway is inside the AKS cluster, so we don't see it in the Azure portal anyways. And now you should have an overview of all the resources we have created. With this said, let's switch over to the terminal and create the gateway. Back in the terminal, I'm going to copy the configuration of the gateway and then we take a look at it. So again, I'm defining everything inside a variable so I can apply this variable. The type is gateway, so that's a Kubernetes resource. Then we provide the name of the gateway and the name of the namespace. Then here, this is something Azure specific. We have to provide two annotations. Usually gateways don't need annotations, but because we're using Azure, we have to provide, again, the name of the namespace where our ALB controller is deployed, and also the name of our application load balancer. Next up, we have the gateway class. This is the one Azure provides since we're using the Azure container, the Azure Application Gateway for container. Horrible name, but since we use this one, we can use the gateway class it provides. The last configuration is for the listeners, and as you can see right now we are listening on port 80. This is HTTP, and we allow all routes, and we also allow the routing to all namespaces. This is something we are going to take a look in the next video, where we're going to create a couple HTTP listener, and also in another video we're going to create HTTPS listener, and we're going to link it with TLS certificates. This means here in this gateway, we can configure everything, how we can access our cluster. So once we have configured this in the file, we can apply the variable. And also let me know in the comments if you like this approach to have everything in the terminal and not in separate files. My thought about this was, it is easier to have everything inside there and you don't have to look up different files. I don't have to open different files. But if you prefer different files, let me know and I can change it for the future. So this takes around 30 seconds until it is deployed. But what we can already do is a kubectl get gateway. Then we provide the name of the gateway, the name of the namespace, and we print everything as a YAML file. And here we can see we don't have any error message. So that's already a great indication that everything worked as expected. And up here we have the message saying application gateway for containers resource has been successfully updated. Then the status is true, no failed or not working, nothing. So all of this is great. If you scroll up a bit, we can see even more information about the gateway. So everything here is also valid. Here we have the configuration. This means we have the gateway class we configured before, the listeners, the annotations. And what we're missing here is the host name, because this takes around 30 to 60 seconds. So let's clean up the window and execute the command again. Now we can scroll up again and then we should find our host name somewhere in here, and there we have it. This is the host name of our gateway. What is great about the gateway compared to the ingress is that it uses a host name. This means we can have a CNAME record and we don't have to rely on IP addresses. So what we can do is we can open this value, just type it into the browser, and our request will go to the gateway. And then depending on what the gateway has configured, it will be redirected to our backend. Since we don't have a backend yet, there's nothing you can route to, and we would get probably a 404 error message. But in the next video, we're going to set up our applications and then we can use this host name to access them. Also in the future, I'm going to show you how we can configure our own DNS, and there we can create CNAME records and point to this host name. Therefore, we'll be able to use our own domain, and we will also be able to create TLS certificates and use HTTPS. What's interesting about this is I have created this application gateway a couple times over the last weeks and then deleted it again, but I get the same host name all the time. And it seems like to me that the application gateway is not fully deleted. I can also see in the log sometimes a configuration or something from before. It doesn't change anything, you're not charged for it. It's just interesting to see that it's not fully cleaned up. This is everything I wanted to show you for today. It's not the most exciting demo and we don't have sample apps or demo apps working right now, but I think the video is already long enough and today we set the foundation for all the following videos. So to quickly summarize, what we did today is we created this new AKS cluster in the green box. Then in this red box, we created and configured our ALB controller, the application load balancer. This means we created a connection to the Azure Resource Manager, and we also created a link to the VNet and the subnet of our AKS cluster. With this configuration, we were able to create our application gateway for a container here in the blue box. This means from now on, we can use the application gateway to do the resource intensive work, for example, TLS termination, routing, and so on. This means our AKS cluster doesn't need these resources. And once the application gateway has done it, it will send the traffic to this blue box, that's the gateway, inside the cluster. And in the next video, we are going to send it from the gateway to our demo applications. So we're going to create 2 demo applications, and depending on what kind of request we're sending, will be either sent to the application A or application B. If you followed the entire demo and it's still confusing for you, please let me know in the comments, but also keep in mind this is totally normal. For me, this whole setup was one of the most complicated setups I've ever done in Azure, and it took me a couple days to wrap around my head about everything. Also, the documentation is not bad, but it doesn't fully explain what's happening, so I needed a lot of trial and error to figure out what's going on. If it's still confusing for you, don't worry. Over the next couple weeks, I will have more and more videos where I show you all the details, and then it should become clear. If you have any questions, always feel free to write down in the comments. And if you have any suggestions for future videos, also let me know in the comments. If you liked the video, I would highly appreciate if you could like it. It will help to share it to more people. And with this, I'm excited to see you next week for another video.